So far, all of our motion has been talking about something on a surface. You know, it might be on an inclined plane, but the only motion that was possible is up or down the plane. Or be on a surface, you could either go back and forth on the surface. Now the difference is now is we're introducing another dimension. In other words, we're going to be actually moving in two directions at the same time. In talking about, and the term for that is actually, we call it projectile motion. And that's shooting things. Once I take my object, my dart in this case, and I squeeze the trigger, what actually happens in here? Well, when I pull it back, it compresses a little bit of air, and that air then propels the shell out of it, out the end, like that. Yeah. This is a good attention getter. I got one more. Now, once the shell leaves the end of the barrel, is it being propelled forward anymore? No. Does that mean it's going to move? Oh. Does that mean it's going to go in a straight line? Not necessarily, because once it leaves the end of my barrel, I'll shoot this way so you can kind of look. As it leaves the end of the barrel, what happens to it? It starts to fall, right? Why? Gravity. Once it leaves the end of the barrel, what are the only force acting on it? Gravity and air resistance. Okay, we're going to pretty much ignore air resistance again, just because it makes our calculations easier. We're not going to in here. We're not going to take air resistance into account because depends on the object and how it's flying and things like that. But the important thing about projectile motion, now once it becomes a projectile, it follows that curve. We have a technical name for that curve. Trajectory. That's its trajectory. But the important thing about projectile motion is that the two components are independent of each other. They are vector quantities. Forces are vectors. The only force really acting upon it that we're going to consider is gravity. Gravity only acts down. So does that have any effect on its going forward? No, because they're independent of each other. Here's a question for you. If I take my gun, take a regular gun even, which I can't bring to school. Not even I can do that. But if I take a gun and I aim it horizontally and I shoot it, where does the bullet land? In other words, where will it hit the earth? Somewhere over there, right? Way down there. How long does it take to hit the ground? I've got a launcher here. Now my launcher, it's a spring action. I pull this back, the spring comes back. If I release it, this comes out this end. Okay? Notice it sticks out this end. Now I'm going to take a marble and I'm going to, or a steely, put it on this end. I'm going to put another marble here. Okay? Now when I release the lever, what's going to happen to this one? It's going to go flying out, right? What's going to happen to this one? It's going to go straight down, right? Because there's nothing kicking it that way, backwards. It's just going to, when this shaft is gone, like that, it's just going to drop. Okay, now, which one's going to hit the ground first? The one that's dropping straight down or the one that's going forward? Listen. What I want you to do is I want you to listen. You're going to listen for the click when they hit. Which one did you hear first? Neither. They're at the same point in time. Why? Because the same force of gravity is acting on them. So they're going to fall down at the same rate. What's the difference between the two? This one was traveling that way. Does that matter to it? No. That just means it's going to land over there further. The two are independent of each other. If I took a gun and I shot it horizontally, and at the same time I shot it, I dropped a bullet, which one would hit the ground first? Same time. What determines how long that bullet that I shoot horizontally is in the air? How high I shoot it from. If I'm shooting directly horizontally, we're going to talk about shooting at an angle in a little bit. If I shoot directly horizontally, if I hold the gun up here or down here, which one's going to hit the ground first? Down here. Why? Because it has less distance to fall. It doesn't matter to the bullet that it's going forward. It's all it realizes, once it leaves the end of the barrel, it starts to fall. Two components of velocity then. Horizontal. So my marble with a hole on it that I put on the back end of my launcher, when that pin goes through it, what's its horizontal velocity? Was it traveling horizontally at all? No. So it's 0. When the pin hit my other one, did it have a horizontal velocity? Yeah. Now, once it leaves that pin, or once my bullet, my dart, gun, does its horizontal velocity change at all? If we ignore air resistance? Then no, it doesn't. Horizontal is determined at launch. Once it leaves the end of the barrel, inside the barrel, my bullet is accelerating. It can only accelerate while it's in the barrel. Because once it leaves the barrel, there's no more force. The only force acting on it is gravity, ignoring air resistance. So it's considered to be constant. Vertical comes from gravity. And it gives rise to the parabola of a trajectory is always a parabola type shape. It's not circular. Parabola is going to increase and go faster and faster and faster downward. Vertical also determines how in the air. If I fire horizontally, I can only be in the air until it hits the ground. It's going to fall as if I dropped it, as if I shot it. Those two quantities are independent of each other. They do not affect each other, but the laws of motion apply to each. We are not going to learn any new equations right now. We're going to take the same equations and apply them. Same thing that we've been doing. It's just now we're going to do it in 2 dimensions instead of 1. All right, so equations of motion apply to each one. They are independent. No, yes, yes, yes. As an example,